Good afternoon. We will continue with our introduction again today, and we will briefly review what we have been doing yesterday. We first discussed what a database system is, and a database system consists of two parts. One is called the database, which is a set of interrelated data expressed in some organized fashion, and second is a retrieval and processing mechanism. This mechanism is often called the query and update mechanism, which is used to ask queries or questions and retrieve information from the database, or you may also process the database in the sense that you may insert new information, you may delete more information, and you may also change or update or modify some information in the database. And this database is generally developed and designed for multiple applications. It is designed for a particular problem, for applications which are generally known to occur today, and for some applications which may occur from time to time. Compared to the early information processing systems, we discussed their faults, and we found out that a database management system attempts to provide a mechanism for organized development of applications in an integrated manner. This was the core problem, the problem of unorganized development of an information processing system developed by various people over a period of time, and that resulted in redundancy, and that redundancy also resulted in inconsistency, and database management system should provide a means to prevent this redundancy and the subsequent inconsistency that occurs out of it. The problems of concurrency are coming up because database management systems are now used by multiple users simultaneously over one or multiple processors, and therefore handling concurrency is an important issue, because shared information, updation of shared information under different circumstances leads to different problems, and these have to be handled very carefully by a database management system. Another feature is the feature of security. A database is designed globally. For example, a railway reservation system will have a lot of people, a lot of information regarding trains, stations, tickets, bookings, and so many other things, fares. Now every person need not know all information, and therefore when you define the database, you will define levels of users who will get to see what portion of the database and who will get to process what portion of the database. It is just like access rights, read, write, and update access rights which are provided. And the last thing is integrity constraints. Integrity constraints are constraints of logical nature. For example, as I discussed yesterday, a checking account cannot be less than a certain amount, or you must ensure that if you have deposited some money and withdrawn some money, the balance must match. And another crucial example we have seen, that you can suppose a train has been cancelled and you've got a booking on that train, then this data has to be properly seen, because this data is of a peculiar type and it has to be handled separately. So what are integrity constraints? They have to be specifiable at the data definition level, and these will be automatically checked during the updation mechanism of the database. So database will take care of allowing definitions of integrity constraints and automatic checking of integrity constraints during processing. So these are some of the core issues which database attempts to tackle. We also saw that an application program is not directly allowed to access files as in a traditional file processing system. The database management system is the software which is provided here, and that accesses the file system according to the type of database which is being defined and declared. So it provides that intermediate software tool for defining and using your data. In order to be able to define and use the data, a database management system must have a data definition language. A data definition language is a language in which you are able to define your database structure. What is the database? What are the data that you require to store in the database? What are their structures? How are they organized? How is one data related to another data? What are the constraints which have to be satisfied? What are the integrity constraints which have to be satisfied? Which data is shared? How will sharing take place? All this has to be defined in the data definition language. That is, the whole organization of the database will be defined in the data definition language. The data manipulation language is that set of software tools by which you process this data manipulation language, data definition language. So, a data manipulation language is just like your set of programs which are used to work on your data, procedures. But this data manipulation language, like this data definition language, will be defined in a structured and organized manner. This will not be just like a traditional programming language, it will have a lot of additional features. These additional features include a much higher level specification mechanism in which I can ask to retrieve certain information, I can ask some processing to be done in a manner which is not as procedural as a traditional programming language. For example, I may want to know which trains are currently late. So, for that I need not have to write a program knowing each and every detailed structure. The data definition language and the data manipulation language will be so designed that the manipulation language is reasonably higher in level of abstraction compared to a traditional language, but it will also have a lot of procedural parts to it. A portion of this data manipulation language, abstracted out portion of this data manipulation language, which is usually of a very higher level and is used to ask, just retrieve some information from the database, is called a query language. A query language is a language which is usually non-procedural or procedural in a mathematical format. It is provided in a mathematical format, and here for example, here this one you will have to compile, but this one, for this you can automatically process the database from this query language. We will see examples of this later on. And other than these, see, for a data definition language, a database management system must have a DDL compiler. For a data manipulation language, it must have another compiler. A query language is also a language, so it must have a processor, because here it is not compiled into object code, but it is directly processed and the database is accessed. And all this has to be done by a piece of software which accesses the file management system and takes care of all the issues which we saw earlier, the issue of security, the issues of concurrency, and other issues like backup, recovery from failure, backup, checking of integrity constraints, and all these things will be done by the database manager. So, let us now see a little more detailed view of the database management system, something which we saw yesterday. Now, what are the types of inputs that can come to the database management system? The database scheme may be defined. We saw the scheme is the data definition. It is the structure of the database which we call the database scheme. So, the scheme may be defined. Application programs may be written. These application programs are going to process the data which is defined in this database scheme. Among the application programs which process it, generation of data is also part of this processing. Queries are questions which are asked to this database for retrieval. And APIs, or application programming interfaces, are menu driven interfaces. For example, at a terminal of a railway reservation system, a person works on a fixed menu, reservation, cancellation, or other types of predefined formats. The person working on an API cannot write any programs. He can just enter some data into some forms and that data will be loaded. So, it is a completely menu driven mechanism. Application programs can be written by various types of users. users who have got various views of the system, and even the general system manager or the system administrator. Queries can also be asked by various types of users. They may want to know many types of information. For example, you may go to a library database and ask for a book. Where is the book? Who has issued the book? Or you may ask when will the book be returned? How many copies of a book, particular book is there? So these are the types of inputs which we have. Now how are these inputs processed? The database scheme is defined in the data definition language. Now once it is defined in the data definition language, it has to be compiled. Now once it is compiled, the structure of which you define for this database will be stored somewhere. It is going to be compiled, and what is going to be the output which is going to be generated from the database scheme is the structure of the database which is going to be stored. For example, now you will decide that these files will store something, these files will store this information, that file will have, for example, I may keep the train information in a particular file in a particular format. Here I just define the train information, and then I will store this in a particular file in a particular format. The data regarding all these trains will be stored here in the data files. But the structure, that is what is the format of the file, what are the fields, what are the width of the fields, how are they stored, all the files, all the information will be stored in the data dictionary, because otherwise you will have to interact directly with the file manager. We will see the use of a data dictionary very soon. Now what happens to an application program? An application program is written in the data manipulation language. It will be written in DML. Now it will have to be compiled, and once it is compiled, since it is a program, what will be generated? An object code will be generated, executable object code will be generated from this program, and this executable object code will be run after this compilation is over. Now when this executable object code written in a DML will use the data structures which are defined in the DDL. Is that all right? It will define the schemes which are done in the DDL. Now, so it will use the data structures of the DDL, and therefore at this point of time you are not aware of what is the file format, which file the data is stored, which file should be accessed, because this object code, other than memory based processing, it will have a lot of read write processing of the structure of tables and records and other types of information which is stored here. It will access, the DML program will access that based on the structure defined in the DDL. Therefore this object code will not be aware of the details of the file structure. How is the information or the data stored in the file structure? That, therefore it will not directly execute the code. For many aspects of the code, especially the read write and the file processing aspects of the code, this will consult the database manager. Now the database manager will look up the data dictionary, find out what are the detailed structures stored in the disk. This is the disk, and what is the structure stored in the disk? The data is stored in data files and the structure is stored in the data dictionary. The database manager will have a look up here, will consult the data dictionary and then see what is the query required, and will now issue the file system commands to the file manager. Once it issues this file system commands, this file manager may be an operating system file manager. So it will issue the file system commands to the file manager, who will now directly access the data files, because this is now going into the operating system. Sometimes file managers and file accessing may also be written by the database itself. We will come to that later on. For the time being, let us assume that the file manager will return this information from the database back to the database manager, and the data will be passed on to this object code. APIs or application programming interfaces are pre-written application programs which can only be run here. So whenever they are run, the object code is invoked and it is automatically executed. What is a query? A query, as I had mentioned, is a portion of the data manipulation language where you can ask, retrieve information using some high level calls. And here it is not compiled always. What happens is, query processor can generate directly the commands required based on the structure of the database scheme and ask the database manager, who will retrieve the information from the file manager. So this is a very interesting and important aspect of a database system, is the concept of a query and the concept of query processing. The application programs may be procedural codes with embedded queries. Queries may be embedded. It is like a C program with some high level calls embedded in it. Okay. So sometimes for DML compilation you may require a query processor who will return you what is to be done at that point of time. The data files are stored here, and we will see there are other things regarding data files called indexing. The data files may be indexed, that is organized in particular fashion so that accessing is easy. There are various types of data files, and for a particular type of a structure we may require a particular organization of a data file. Let us look at it in another way. Suppose you write a program. In your program you normally do a data definition, and then you write some procedures to solve that problem. And the whole issue of programming and data structures is to write efficient programs, and that efficiency is relative with the amount of time and space which is required by the program. The programs that we normally use are sorting, searching, these programs, and these are normally memory driven programs. And whatever data structuring that we have studied till now has been defined for working on the memory. For example, if you remember heaps, you remember priority queues, you remember the trees, the binary search trees, and various other data structures that you will know, are all based on memory. That is the standard technique which we do in programming and data structures. Here it is, we will see later on, that this data has to be organized for efficiency. Efficiency is a very important aspect. You cannot spend all your day just retrieving information in a arbitrarily long unwinding fashion. So the structure of storage and data structuring is also important in a database, and this data structuring in a database, the major difference is, in normal programs the data structuring is focused on the memory. Here the data structuring is focused on the disk. The problems related to data structuring will come up in a new guard in database management systems, and if we have understood those properly, we will see that it is just a translation with appropriate ideas, issues taken into account. We will see that the same ideas which we use to develop data structures in standard programming will be used to develop our file structures in database. Another idea which has been studied before in traditional computer science will come to use in database management systems. That is our study of operating systems. The traditional time shared or multiprocessing operating systems, the major problem there is handling of concurrency. How you handle concurrency is the basic issue of database program in operating systems. In operating systems, the base issue which we try to tackle is that of updation of shared information. If there was no sharing of information, then operating systems would have been simpler, much simpler. Synchronization, sharing causes a lot of difficulties in the design of operating systems, and there are a lot of theories and lot of techniques by which we resolve those. And you will see those techniques like semaphore operations, synchronization, mutual exclusion, all those things which you have studied in operating systems are all applicable on the memory. In the database, these things come again in a new dress, but everything which we do is related to working on the disk. So the problems of concurrency tackling, the theory and techniques of concurrency tackling will come back to us in database management systems, that we have seen. but the solutions we will derive from the solutions that we have seen in traditional traditional operating systems. So these are two things which we need to keep in mind when we really work out our design of a database. There are other aspects, and another important aspect is recovery from failure. Normally whatever happens, our programs, anytime a program gets destroyed, what happens? We just run it again. But you can imagine suddenly you are running your programs in a database and power goes off. Now 1500 people all over the city were using this database. This power goes off, 1500 people were doing various types of things, and therefore the recovery from failure or recovery from crash is a very important issue, because firstly the database cannot be corrupted. We are not working on memory in the sense that you run the program again, okay, everything is loaded into the memory again. Here the database is existing, we cannot allow it to become inconsistent, we cannot allow it to crash, and many other things. We have to decide on which procedures to rerun, which procedures not to rerun. So recovery from failure will be an important topic in the design of a database management system. Database management system is related to designing of what should be the structure of a DDL, what should be the structure of a DML, what should be the structure of a query language, how will they be these people be implemented, how will the data be organized, and system related issues like how will we recover from failure and how will we tackle concurrency. This is in very brief the core of database design, the total aspect of database management systems. But let us discuss something which comes before all these things. For example, if you are to write a program, before you write a program on the computer, somehow from somewhere you solve the problem in your head, and then you translate into the program. Whatever is taught in programming, this how you solve it in your head is never taught. It possibly cannot be taught. It comes through experience, it comes through practice, and it comes through something called intelligence, which is difficult to define. Here also, the first thing before you write out the structure of a database, you have to really imagine and design it conceptually. Therefore, conceptual design of the complete database is the first and foremost issue in any database design. And therefore, whatever we have discussed here, all this starts after you have really conceptualized what your database is, and that has not yet come. So we must first, after we are able to conceptualize what the database is, only then we can define the scheme, and then we can start writing these. So unless we are able to conceptualize that, it becomes very difficult to really start designing a database. So other than all these things, the most important issue is the concept of designing the database conceptually. For that we need some tools, and these tools are called data models. Data models are tools for conceptually designing a database. I have said before that a database management system consists of a database which is a set of interrelated data. But how do you express this data? How do you conceptualize this data? And how do you really start formalizing this information is what we will require to know in data models. So data models forms a core aspect of database design. There is, like you can really solve a particular problem in a number of ways conceptually. For example, you may find the minimum of n numbers by a iterative program. Iteratively you can conceive it. you can conceive of it inductively or recursively. Therefore, similarly, data models can be conceived and imagined in various types of formal mechanisms. Among them, the entity relationship model is usually the most commonly used such data model. It is a conceptual model based on certain objects and logic. It is a logical object model. That is what is an entity relationship model, and we shall come to ER models as they are called for quite some. Later on we shall come to it again and again, and we shall discuss ER models in details in this course. Another type of an object model is now the modern object oriented data model. This is another object model. Another object model is the semantic data model, and some other models like the functional models are also. These models are not so much directly related to the implementation aspect. It is a very logical and a very high level view of the structure of the database. It is later on going to be translated to a lower level model. Among the lower level models are the record based models. These are often called the record based models. Of which the relational model is by now the most popular and most widely used model. Next comes the network model, and we have the hierarchical model. We shall now briefly see these first four models and what they mean. These we shall tackle later on as and when the situation arises. Let us come to the entity relationship model. We are just giving a brief idea of the entity relationship model just today. We shall discuss the entity relationship model in details in a subsequent lecture. Now, suppose you want to express some, you want to conceptually model a library. So, in the entity relationship model, you are asked to identify some of the basic entities or structures or objects which are the core of that particular database that you are going to design, and these are called entities in the entity relationship model. For example, you can have the entity book. Now, each entity will have a set of attributes. For a book, we can have several attributes, and those who have seen in a library, for a book, one of the attributes is the accession number, another attribute is the title, a third attribute may be author, a fourth attribute may be year of publication, a fifth attribute may be publisher, and you may have several other attributes, price, etc. I am not writing all of them. So, you have to identify the entities or the core indivisible elements of the database that you are going to design. A second such entity can be the set of users of a library. We are designing a library database. Now, for these users, you will have, for each user you will have a set of attributes. The first attribute for a person to be a valid library user, you must have a card. We will assume that these are only related to users who issue and books and all these things. Those who generally come in and go, we are not putting them in this user list. You will have name. Let us assume that we are doing it in this institute. Address, status, student, faculty, staff, and a code. For a student, it may be the roll number. For a staff, it will be employee code and various other types of code. You can have several other types of entities in a particular library. You will have the suppliers who supply the books. Okay. You will have the people who work in the library. They will form another set of entities. Okay. They will form another entity set, as it is called. But we will, for the time being, let us consider only two. Other than entities, you have what are called relations. These relations are the interrelationship between entities are expressed as relations. And one of the most common relationship between books and users is the borrowed by relationship. This is the relationship which will map a particular book to a particular user, provided that this user has borrowed this book. So, this is called a relationship. This is the book currently borrowed by this user. Now, all users, some user may not have borrowed all the books, all books may not have been borrowed. So, it does not mean that everybody will have a connection with everybody out here. It is just, this is a set of books, this is a set of users, this is a set of relationships saying that this user has issued this book currently. And even these can have attributes. For example, yes, a date of issue can be an attribute. This attribute is neither an attribute of a book, it is neither the attribute of a user, because a user may issue more than one book. Therefore, date of issue is an attribute of the relationship between book and users. Therefore, in an ER model, you use the logical ideas of entities and relationships and the attributes of entities and relationships, and you model this in. This is a diagrammatic representation. You can also have a structured program language representation of an ER model. This is just a diagrammatic representation, and in this diagrammatic representation you can express many types of constraints which are there. For example, you can say that one book cannot be borrowed by more than one user at a particular point of time. You can have a constraint saying that if the user has got this status, then the maximum number of books which can be borrowed by this user is so much. You can have a constraint saying that these books are there in the library, they are reserved books, they cannot be borrowed by anybody outside. They can be borrowed by a special status. For example, if you want to Xerox something, etc., etc., there are means of doing so. So, that borrowed by maybe have to be done by a different relationship. This relationship will not take care of those borrows. So, constraints can be defined here when you define the conceptual structure of the database itself. So, this is the idea of the ER model, which is a conceptual model. Here you do it in a logical framework using the idea of entities, relationships and their attributes. Next we come to the relational model. In the relational model, we are slightly more down to earth than the entity relationship model. In the relational model, we express all our information in terms of relations or tables. For example, let us go back to the problem that we have now been tackling. We have one table for book, and that table will have a number of fields. So, let us look at the book table or the book relation. It will be a table I am just giving you an idea, and there will be several columns in that table. These columns will correspond to the attributes as we look at it in the entities. Therefore, here you will have various columns like accession number, title, etc. Similarly, for users you will have another table. In the relational model, everything is mapped onto tables. It is the uniform structure. All of them are mapped onto relations and all of them are mapped onto tables. Here it will be card number, name, etc. So, this is the user table, users table. And finally, we will have the borrowed by table. In the borrowed by table, obviously one of the fields will be date of issue. The other fields will be the interrelationship between the book table and the user table. So, you can put in all the attributes of the book table and all the attributes of the user table here, but you can also define something else. For example, even in the entity relationship model, you know that the accession number being known, then this becomes unique. No two books can have the same accession number. So, that means if the accession number is known, then all of them become unique. Here also the card number, it being known, you will know the name address. Obviously, two users will not have the same card number. It is not that always one attribute will determine all the attributes, but maybe instead of all of them, a subset of the attributes may determine the values of all the attributes. These are called keys, which we shall come to later on. But based on the idea of keys, here the borrowed by table need to have only the accession number and the card number, and that is sufficient to express the interrelationships between all these values. And all the books which are there will be data elements in this book table, which may be implemented as a file, which we shall see later on. But conceptually it's a table. Users data will be as a table, and this will be as a table. So we have got that little simple library database which we had before in the ER model. We have now got it in the relational model. Next we come to the network model. In the network model, the implementation in terms of records and pointers, which was very little in the ER model, slightly more enhanced in the relational model, is even more direct in the network model. And the network model, in this particular problem, we know that we have got two types of records, books, and we have got another type of set of records which are called users. Each of these records, the attributes of each of these records are known, and the fields of the attributes are also known, because we know books will have certain attributes. So all these attributes of all these records are known. And instead of having a table to represent these two and a table to relate these two, we relate them directly by pointers. Here we know many users can issue books. A particular user can issue more than one book, but one book cannot be issued by more than one user. This is a simple case. We shall see complex cases later, but in this simple case we say this is a many to one pointer relationship. And how will it be implemented? It will be implemented. Yes.
One to many.
This is many to one. One to many is this side. This is many to one because more than one user. I am sorry. This is one to many. I am sorry. This is one to many. It is not many to one. One user may issue more than one book. Right. One user may issue more than one book, but one book may not be issued by more than one user at a particular point of time. So the arrow direction will be like this. And how is it going to look like in the network model? In the network model, let us take a particular user. This is a particular user record. It will have many fields. These are fields corresponding to the card number, name, etc., etc., etc. There will be a link field which will link this up to the books, the record corresponding to the books. So you will have a records corresponding to the books. This is one book, this is another book, this is a third book. And for all these books, you will have their attributes as well as a special link field. Each of them will have a link field. Now let us see how this link field is used to express the interrelationships. This, since a particular user may issue more than one book, then we cannot directly link up this field to, we cannot have a variable pointer concept here. But from a book, let us say this is one book record. This is another book record. And this is a third book record. But since from a book you can always have only one user, you can just have pointers. This may point to this book and this may point to some other book. this may point to this book may point to some other user, indicating that this user has issued this book. But this direction is a little more complicated, and this direction works this way. You put it into a temporary record, a chain of temporary records. You link it up to a chain of temporary records. So this relationship, the whole relationship, this says this is linked to all these, and each of them, this is, so this user has issued this book and this book, and once you drop this link will come automatically. But since this has got a single one, so it will be pointing like this. So in a network model, the entities which we conceive in the entity relationship model are put in terms of records, are conceived in terms of records, and the relationships are conceived in terms of pointers to records. This is the core idea behind the network model, and the network model is more pointer oriented and implementation oriented this way. This is one way of looking at it. It depends, some people look at it in various ways. These are three different ways of looking at the same thing. The hierarchical model is a network model, but here in a network model, since it's a network, you can have cycles, and you can have one person pointing to two people pointing to 5 people, and therefore in general this connectivity is a graph. The hierarchical model is a version of the network model where the connectivity is defined in terms of a tree only. And a hierarchical model is not, if you convert a network model to a hierarchical model, then some records may need to be duplicated. Some records may need to be duplicated. On the other hand, in a network model, since we are putting it as pointers, no records are duplicated. But if a particular record is linked, for example, this user is linked to this person as well as this person. In a network model, this will, in a hierarchical model, this will not be allowed, while this is allowed in a network model. In a hierarchical model, this will have to be made one separate and this will have to be made one separate. But it is useful, the hierarchical model is useful in other applications, in applications where the structure is inherently a tree. For example, a hospital, the hierarchical model is useful in structures which are essentially trees. Take a hospital, and this hospital, or the hospital records of a particular city are broken down into wards, units, and other things. A ward may be broken down into patients, doctors, and other things. A patient, these are all information. Hospital information is broken down to ward information, units information. Units means cardiology unit, this unit, pathology unit. A ward may be broken down, information regarding a ward may be broken down into patients, doctors, nurses, etc., medicines. A patient information may be broken down into symptom, diagnosis, treatment, etc. So here the structure itself is hierarchical, there is tree-like structure, and therefore the model used here is a hierarchical model, which is just like a network model, very similar to a network model. The other data models we will not see immediately, we will see them when we come to the course, and we would just quickly like to see what the whole course is about. And the whole course, the core of the course, which we shall discuss from next day, these are the core topics. The core topics we will discuss first is conceptual modeling. In conceptual modeling is how do you conceive the structure of a particular database. We will go deep into the entity relationship model and see how the entity relationship model is defined, how problems are solved using the entity relationship model. We will also go into the relational model, and we will see how the entity relationship model can be converted into the relational model, where we will see attributes, relations, tables, schemes. In the relational model, we will discuss the data manipulation techniques, of which the query languages, the theory of the query languages, the commercial query languages available, and the data manipulation relationship between these query languages. And among these query languages, we will discuss relational algebra, relational calculus. We will also quickly go through some commercial languages like SQL and QBE. We will go through the network model in brief, but we will discuss the relational model in more details. Next, we will go into design, that is, we will ask that question, is this the best design of a database? We will conceive of a database as an ER model, we will convert it, and we will look at the conversion into a relational model. Then we will see, is this the best design? How do you specify the design? Among them, we will have to specify the constraints. How we specify the constraints and use the constraints. So that will be the topic of relational database design theory, of which the topics will be integrity constraints, functional dependencies, decomposition, and normalization. The other major system related issues, the file system, what is a file system, what it looks like, how is recovery from failure handled, that is crash recovery, what are the methods provided to handle crash recovery, and how do we handle concurrency control. Once we cover these core topics, we may then go into the advanced topics. So today we will end the introduction part of this database management.